is the stuff at the beginning. Bless you.
Wow, that was only like 3. But thanks.
Welcome.
That was really short for me.
All right. So when we go back and start looking at solving the equations in this stuff, you guys will be pleasantly surprised at it's really not that bad. When you're working with radical equations and you're working with this, we're still just working backwards. For example, if we're going to solve for x here, we're going to solve x minus 4 equals the square root of 2x. And when we work backwards with these things, we're still doing the same procedures we've done in the past. We have to undo our way out. What is the first thing you're going to do here?
Square both sides.
Good. So we're going to square both sides. Now, when you square both sides, you have to remember, and this is where you guys are going to screw up, x minus 4 quantity squared, don't kill the puppy. Remember, you have to, it's jump times jump, you have to multiply it out. Alright? So when you do that, you have the square root of 2x squared, so you just get 2x. Now what do you do? Good. Subtract the 2x and then factor it. Right. So we have x squared minus 10x plus 16 is 0. So what times what is negative, or excuse me, positive 16 that you add together to get negative 10?
Negative 8, negative 8.
Good. Which means your zeros are at?
2.
Now, what do you have to do next?
Put them in.
Yeah, double check them.
Right words.
You always want to double check them to make sure they work here because you have to worry about those roots. So we have 2 minus 4 is negative 2, and the square root of 4 is positive 2. Remember when we talked about this at the beginning of the year, beginning of this chapter? When you're working through these, we're working through them literally. We're not taking the square root of both sides to go plus minus here. We're just taking the square root of 4. Does negative 2 equal 2?
No.
So does 2 work as an answer?
No.
It's extraneous. Remember that? That's that extraneous solution. It's the solution that works that doesn't work. Vaguely remember that?
Yeah.
That's what we're double checking here. And then we double check with the 8. 8 minus 4 is 4. And then the square root of 16 is?
4.
Yay! So you wind up with just the 8 working. Not bad?
Not bad.
That's the screwball of stuff that we have in this section.
Until it gets hard.
Not really. I mean, there's not that much nastiness in this, believe it or not.
Yeah, maybe
No, I believe it.
Where is he at? So let's do this. Here's 3 of them. This one is just the square root here. Take a few minutes. There's 3 of them then. Okay?
Sorry, that little 3 thought.
That's the cube root. All right, take a few minutes and solve those out. We'll check. So on the first one, you just had to cube both sides. So you wind up with 2x plus 1 is 8. We got 7. 7 halves. Okay. How do you check that? It's real tough. You don't even need a calculator because, oh, that's right, I won't get one. So when you go to check this, you have the cube root of 2 times 7 halves plus 1, right? What's 2 times 7 halves?
What's 2, right? 14 halves, which is 7.
What's 7 plus 1?
8.
What's the cube root of 8?
2.
2. What's so tough about that? 2 times 7.
No. Still is wrong.
2 times 7 divided by 2 plus 1.
Where is
Oh, double.
There's your problem. It works.
You work for that.
We go to the other one. So you square both sides. Please don't kill a puppy. Get -2 and -1. Do they both work?
No.
Like they did not check.
They both should work. Take a look. What's -2 plus 2? What's the square root of 0? 0. What's -2 plus 2? Does 0 equal 0?
Yeah.
All right. What's -1 plus 2? What's the square root of 1? 1. So they both work. In this case, they both work.
I'm looking up Nemo's
That's not
Somebody thought this was like water, so they put fish in water.
That's awesome.
And then the last one, you square it out.
That's pretty good though.
This isn't mine. This one can be letters.
Moving stuff around. So it's 4 and 3. -4, -3. So let's see, -12 plus 13 is 1, square root of 1. Yeah, that one works. -9 plus 13 is 4, square root of 4 is 2, and that works. So those both work also, right?
Weird, why do you have 3?
Because
They both work.
they're for the sick ones. The sick children.
Let's see, this one, right? Oop. Where's the tough ones?
I bet we should spend a lot of time wrapping all this.
Okay. Now, what happens when you throw fractional exponents in? Exponents.
Well, you got to do whatever.
You got to do whatever you got to do. Okay, that makes a lot of sense.
Now that was just cool.
Yep. What happens here, guys, in order to do any of this work to start out with, you got to first of all have just whatever is raised to the exponent on one side. So in the first one, on 28, I got to get rid of the 2/3. How do you get rid of 2/3? 3 halves. Okay, so x to the half is going to equal 3 halves. Now, how do you undo half?
You square
You square it. Good. Remember, you go to the reciprocal power. The reciprocal of 1/2 is 2. So you square both sides. So x can equal, well, 3 halves times 3 halves is 9/4. Very good. Okay. You're asking what?
What? All right. On the quiz yesterday, there was one where you wound up with like the variable on the bottom of the fraction. What do you do then?
You have to rationalize it still. You have to simplify and rationalize.
No, like it was like y minus 3 on the bottom. What do you do then? You have to multiply by.
Oh, if it was just y minus 3 on the bottom?
Yeah.
Oh, then that's fine because it doesn't have a fractional exponent.
You have to solve for it.
Oh, when you're doing the inverse?
Yeah.
Okay. Yeah. Let's do this one first, and I know what you're talking about.
I just like made up.
I just
Same.
I did my own thing.
What are you going to do first in the next one? All right.
6.
And then what do you do to the exponent?
Multiply by 5.
Multiply to the 5/3. Good. So you go to the 5/3. Now, that basically says what's the cube root of 3 to the 5th power? Oh.
Would you do 3 times 5 is 15 over 3? 5?
Could I just put that in my calculator if I had to?
Oh, yeah, I mean,
Oh,
yeah.
yeah.
Do we know what he's talking
Or do you want it written like -3 plus 3
I'm just wondering if this is actually a normal number. I don't think it's a normal number.
I'll look it up.
Oh,
It's not, is it?
three, like,
So can I just leave it like that?
any over five?
Can I?
No, you have to put it around. Here's the t-shirt.
No, you don't. If it started in the fraction
Oh,
form,
yeah,
you should
sure.
leave it in the fraction.
If it started in fraction form, let's leave it in fraction form.
It's not.
Can I just do that?
Wait, why didn't I just?
That's an exact answer.
Why didn't you just subtract the three?
Because they don't have the same exponents.
It doesn't work. It's 6 points.
Oh, I see what you're saying. Okay. Now, I see what you're saying. You want to do this. 3 to the 5/3 minus 3 to the 3/3.
Yeah.
Okay. If you do that, then what do you get?
2/3.
1 to the 0 to the.
You get 3 2/3.
Okay.
Would we have to do that?
I don't know. I haven't written the test yet.
When is this test happening?
Next week's or sometime next year. Oh, it just never gets old. Yes, it does. Yes, ma'am. Not supposed to wear it in the hallways during passing periods.
So now.
You yelled at me for wearing a hat.
You said.
We were Santa hats tomorrow with our ugly Christmas sweaters.
I'm so upset that I'm not gonna be here tomorrow.
Last one, I'll give you some homework. Last one, then I'll give you some homework.
I should have just worn it today.
So in this case here, what's the first thing you're gonna do? Subtract the 1.
Oh, you should see that first.
Okay, I got to.
Now what?
That's my negative one.
Multiply everything by -1.
What?
Can't have that.
What? If you don't, it's just.
Let it happen.
Well, you want to do that because you can't cube it. You're not supposed to cube it to get rid of that -1 in front. Okay. So if it was like a 3 out front, you couldn't cube it right off the bat. You'd have to divide it by 3. So it's the same basic idea. So now cube both sides, and you get 5x plus 4 is 64.
Yeah.
Yep.
5x is 60, x is 12. So when you go back to double check that, you wind up with negative cube root. Well, we know 5 times 12 is 60, 64 plus 1. So this becomes -4 plus 1 is -3, and it works. I'll give you some of these to try.
Well, that's not what I got for my answer.
This is 7, 6.
7 7 5.
We're going to do that when we get back. So let's see, 24,
Let's say they were even. Let's do it. We'll do it backwards. I don't really care. I think like
so this is what, 441? Let's do those. I'll put that number. So, don't forget, double check for your extraneous because it does show up from time to time. More often than not, though, your extraneous solutions work when you have even powered exponents. That's usually when they wind up. Yeah, we're ready.